This is the BTEC Unit 1 Physics homework book, and we're on to page 5, which is actually question 2. So starting off, just looking at some simple waves. You've done these with the slinky springs, and tell us a little bit about them. We really want to know and describe the pictures here. So we want to know the oscillations, how are they compared to the direction of the wave. So in transverse waves, the oscillations are perpendicular, so sideways to the direction of the wave. So the wave's going along like that, and the oscillations are perpendicular. Perpendicular to the wave direction. Whereas in longitudinal waves, and you've done this with a slinky as well, the oscillations are going in the same plane as the wave. So oscillations are in the same direction or plane. They go backwards and forwards as the wave. So just two little simple points there, and we'll scoot straight on to some example questions on page 7. And question 3, the wave equation. So we need this wave equation. This is one of them that you have certainly learnt, which is V equals F lambda, and this wave speed. So this here is the speed or velocity. So speed or velocity, that's going to be in meters per second. Here we've got frequency, that's going to be in hertz. And we've got lambda, which is our, I'm going to write lambda, which is our wavelength, which is going to be in meters. When dealing with light waves, we represent numbers in standard form, and we need to convert these numbers now into standard form. So standard form is something point something times 10 to the something. It's going to be like that, and our initial number needs to be between 1 and 10. So we've got 300,000. I'll write it out again. So we have 300,000. How many zeros have we got? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 3 with 8 zeros on it. And then what I would do is I'm going to have 3.0 there as my number between 1 and 10. So that's going to be 3.0. And then how many times am I moving the decimal place to get it there? So I'd move it 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 3.0 times 10 to the 8. We've got 4 zeros there, so my number is going to be 1.5. It's going to be times 10 to the 1, 2, 3, 4, 5. 1 the other way now, 0.0014. So my number between 1 and 10 is going to be 1.4. 1.4 times 10 to the, well, it's going the other way this time, so it's going to be minus. And then how many times are we moving it? We're going to move it 1, 2, 3. So 3. It's going to be times 10 to the minus 3 there. Another big number, 8435600. My number between 1 and 10 would be 8.4356. And some questions might ask you to give a particular number of decimal places or significant figures. I'm going to, I'll leave it like that, times 10 to the, so I'm going to have to move it 1, 2, 3, 4, 5, 6, so times 10 to the 6. But look for what the question wants. And 1, I'll write that out again, just 8.4 times 10 to the 6 as well. So just another version of it, depends on the precision. Our last one, 13875. That's going to be 1.3875 times 10 to the 1, 2, 3, 4. Or we could possibly have it won't be 1.3 because we've got an 8 after it, so we're going to round that. 1.4 times 10 to the 4. An example, calculate the speed of water waves at frequency 50 Hz and wavelength 1.5 centimeters. So our equation, just the equation at the top, V equals F lambda, so velocity is frequency times the wavelength, and velocity is a mystery, that's going to be in meters per second. Frequency, it gives us a frequency there, so I'm going to write that out, 50 Hz. Wavelength, our lambda, we've got 1.5 centimeters, and we certainly don't want centimeters on this occasion. We're going to convert it to our standard unit of meters. So if we convert that to meters, there's 100 centimeters in a meter. So we're going to have to divide that by 100. So 1.5 divided by 100, 0.015. So you could have done that in your head, but I was just showing you on a calculator there as well. So meters. That's one of the most common mistakes in these calculations, is not to convert the units to what you want before you start doing the calculation. It's always harder to do later on. And so we've got F 50 times by lambda 0.015. Put that into the calculator, and that is 0.75. We need to stick the units on or else you won't get the marks, so that's going to be velocity, so meters per second. More example calculations. Calculate the wavelength of electromagnetic radiation at frequency 5.0 times 10 to the 15, and we know that the speed of all this radiation is similar to the speed of light, 3 times 10 to the 8 meters per second. So we're going to start off with our normal equation. Always start off with the equation you want, and we are calculating the wavelength. So we want wavelength on its own. So how do we get rid of frequency on this side of the equation? Well, we divide it away and that'll get rid of it. So Vf equals lambda. I'm just going to turn that around to make it look better. Lambda equals V divided by F. So we're dividing it. And so what we ask is calculate the wavelength. So wavelength is a mystery, but we're going to have that in meters. V, and we have got, here we are, 3.0 times 10 to the 8 meters per second. Our frequency is 5 times 10 to the 15 Hertz. So this we've put this in the booklet just to see whether you can use your calculator putting these numbers in. So our calculation is 3.0 times 10 to the 8 divided by 5.0 times by 10 to the 15. Let's see if I can put that in the calculator. 3 expand times 10 to the 8 divided by 5 expand 15. Press equal, magic button, and we get 6 times 10 to the minus 8. So it equals 6 times 10 to the minus 8. And what units are we going to have there? Well, this is wavelength, so we're going to have meters there. G, calculate the frequency of microwaves of wavelength 2.8 centimeters. You should immediately get suspicious now of this 2.8 centimeters, and we're going to need to convert that to meters. So start again doing exactly the same thing. V equals F lambda. Calculate the frequency this time, so we need to get rid of lambda on this side of the equation, so let's divide by lambda. So V divided by lambda equals frequency. Just swap that around to make it look nice. Let's write down on the right hand side what we know. So our frequency is a mystery, but that's going to be in hertz. V, well, this is microwaves and they are in the EM spectrum, so our velocity is the speed of light still, so 3 times 10 to the 8 meters per second. And lambda, well, it gives us our wavelength there, so 2.8 centimeters. We're going to convert that into meters, so it's 100 centimeters a meter, so 2.8 divided by 100, that's 0.028 meters. And now we can stick this into our equation. V, 3 times 10 to the 8 divided by lambda, 0.028. So let's stick that in. 3 times 10 to the 8 divided by 0.028. And that gives us 1.07, so let's just go 1.1 times by 10 to the 10. And what units do we want for frequency? We want hertz. And then just a little extension part here. In what region of the electromagnetic spectrum are the waves in part F? So these are yeah, so it's just a question of looking it up on the electromagnetic spectrum table. By now, actually, by the end of the unit, you've done the EM spectrum, and you can look in your book, and hopefully you found out that this was ultraviolet. So UV, ultraviolet, ultraviolet, and that's the end of question 3.